Last night I was on a YouTube with the Vintage Computer Federation, and there were panelists who were in the early history of educational technology. So there was Cynthia Solomon, who worked with Seymour Papert when Logo was being developed, and she saw like the actual turtles on the floor, the robot turtles.
Right.
And then Liza Loop met Steve Wozniak, and she has an early Apple One that she was lugging to school and showing kids this is a computer. Now let's learn assembly language. Imagine that. Well, they had integer basic. So that's but she's researched a lot over the years, and now she's working on a project called Kepler, which would be an artificial intelligence recommender for educational materials for people motivated to learn, having a specific learning path. So that's an interesting, but she's interested in other areas of research as well. One thing she talked about was active learning, that's now a priority among national education, to not to just have kids sitting in classroom doing drill and practice. So, and then the other panelist was Brian Silverman, who is from MIT, and he made several variations of the Logo language and extensions to it for various computers. So a lot of experience from the 60s, 70s, and 80s that we can draw upon. So that's recorded. It's on YouTube. But what I was curious about from Barry is his experience with multi-user dungeons being used in education, and to explain Micromuse a little bit.
Yeah, sure. So in around 1990, I joined a group at Bolt, Brannick and Newman, BBN, the company that really did invent the internet.
Mm-hmm.
And they had a small department there that was doing educational technology research, headed up by Wally Forsythe, who died about 5 years ago. And they had National Science Foundation funding to develop educational content for computers and the internet in these early days, in the early 90s, when basically computers are just becoming available to schools and to school children. And I joined them as a visiting scientist around 1990 and worked on a number of projects, some of which were funded from the NSF to develop software applications, but also was doing unfunded work. And I knew about the MUDs. The MUDs had started around 1987 as a project that, among others, Michael Malden had developed at Cornell. He was is interesting. He was actually trying to develop robots that could do natural language processing, and he needed a contingent of people to talk to the robot, and so he recruited the then existing MUDs, the sort of the mid-1985 early MUDs. And that's one of the reasons they became popular, because people were going on not only to talk to his robot, Julia, but also to each other. And I discovered the MUDs around 1990 and thought, gee, I wonder if we can adapt these for education for children. So I helped found one that ended up being called Micromuse.
Okay.
And Micromuse Micromuse is, by the way, still on the air, although it's really a ghost town. But it was very active in the decade of the 90s. It mainly ran on a computer at MIT that Hal Abelson had loaned us.
Do you know what type of computer that was?
Yeah, it was a Motorola System 5 machine that Motorola had given them this computer because they had a version of version of Lisp. They had version of Lisp on it. I don't remember the name of the version. I don't know.
Yeah. Well, MIT was the development of Lisp.
Anyway, they had a version of System 5 Lisp on it, and that's why they had the machine. but it was basically idle because they were really using Hewlett-Packard machines mostly in those days.
Mhm.
So he let us have it for Micromuse. So we ran Micromuse on that computer for about 5 years, and then he said, take the machine physically out of the building, it's yours. We moved it up to UMass Lowell for a while, and then it gradually evolved it to more modest, smaller, but physically smaller, but equally powerful machines. And now it runs on a Sun Ultra machine in my living room.
Nice.
I ran it at BBN for a while on a smaller machine. Forget exactly. I think we ran it on VAX machines. To run on VAX machines, I forget now exactly. Anyhow,
Fascinating. Yep.
So it's technically been running for 24 years.
That's so cool. So like, was it like a BBS where people would dial up back in the day to it, or like, did it have a modem pool, or?
No, it was on the internet. It was always
Yeah.
on the internet. And so you had to be on a computer that had internet access, which in the early days, it was really, was it Cincinnati? What was the town? One of the towns in Ohio
Mhm.
was one of the early ones that had community access.
Okay. So like a cafe where people could go and use the internet.
Well, actually, no, they had a dial-up system. I'm trying to remember which
Right.
it was. It was
Yeah, remember the days of dial-up networking?
Oh yeah.
Yep.
But the thing about the MUDs is that you needed a client, and you used the client over the internet to log in,
Okay.
and then it was a buildable world. It was a persistent world.
Hmm.
It had a very primitive programming language, which is object oriented,
Oh, cool.
and so you could build objects. And the very first versions of the MUDs were quite primitive. You basically it was just a web of rooms, a dungeon. You had rooms and exits between rooms, and not much else. I mean, I guess eventually objects. And so the MUDs evolved through a series of evolutions, MUDs and Moos and Muses and
Right. Okay.
ours was called Muse, and it was Wally Forsythe who proposed the acronym Muse, multi-user science education.
Oh, cool. So like, was that related to your work with the museum, like the science education? Like, did you
Well,
try to bring some of that
it was
into
in
it?
parallel. So
Yeah.
my character Moulton, I'll
Hmm.
tell you, when I was at BBN, and the very first time I logged on to a MUD, or I think it was a MUD, you had to pick a screen name.
Hmm.
So I'm staring out the window of my office at BBN at the intersection of Moulton Street and
Oh, cool. Yeah.
what was it? Concord Avenue.
Uh-huh.
And I'm staring at the street sign, and I know that I don't want to be known as Concord Avenue.
Okay.
So I write down Moulton. So I become Moulton.
That's so cool. Yeah.
And that was around 1990 or so. And so my persona Moulton, and I modeled Moulton after my science museum real person. So in the science museum, I'd go physically, and I had all these little manipulable items, these little science toys. And I recreated everything. I recreated Moulton on Micromuse with essentially the same stuff. And I created a little science museum online. And so I basically had two versions of myself, the real version on Saturdays and the synthetic version on Micromuse.
Cool.
And that sort of became my avatar, my identity.
Yeah.
And
Now what's interesting is the manipulative objects, because that was mentioned in last night's talk, that like the Montessori schools, that's what they're using,
Right.
manipulative rods and things to get more active learning. And I guess for kinesthetic learners, that would help a lot.
Yeah.
Yeah, so it's interesting. So like the parallel to the museum and the online, so what kind of like experiences, like to translate a manipulative to an online environment, how did that work?
So first of all, you give an object a name, and the name was essentially the same name as you would give it in real life.
Okay.
And you give it a description, which is basically a paragraph of text that what it looked like when you looked at it. But then you gave it behaviors.
Okay.
And the cool thing was that the Muse or the MUD language had ability to code behavior. So when you engage with the object, you could
Mhm.
pick it up, you could drop it, and you could do other gestures. You could define arbitrary gestures, just verbs that would.
Yeah, like a ball drop, or
Right.
ball bounce. Yeah.
Right. So and typically the description would cue you into what the available gestures were that you could do with it.
Okay.
So then you would code little snippets of code that would give the reactions. The reaction was all done in text. So you would
Okay,
do
so
you would do
like
a gesture, and then the thing would be like a talking Coke machine that would say, "I'm now dispensing."
So
And
like, say you were holding a ball and you want to drop it and do measurements every second, could it do something like that? Or
it could, although the sense of real time wasn't there because it was just simply a reaction. So you could
okay.
put a delay in. In fact, we did put sequences of responses that would have a time delay between them. Um, but nothing quite so fast as watching something drop. It was because remember you had to send a sentence, and we're only like
Okay.
300 baud, and people had terminals that were only like reading.
Yes,
You
I
had
remember.
to read, and you can read
Okay.
about 30 characters a second. So
Yes, I'm trying to imagine what type of lesson you could do with that. Can you just give us an example?
So, in fact, you can still log on to Micromuse and go to
Yeah, later we'll talk about
the
that.
Science Museum and play with some of the toys. So, for example, I remember some of them. One of the things you could do on Micromuse is you could make objects that you couldn't have in real life. So I had a tesseract.
Oh, nice.
So the tesseract, you could pick it up and it would give you a description of itself. And when you dropped it, it would turn itself inside out. It would.
Nice.
So but you could have really complicated things. So I had a logic puzzle that I stole from Raymond Smullyan, the Island of Maya, the Knights and Knaves. So we had Knights and Knaves puzzles, which was a whole collection of islands, which literally was taken almost verbatim. And actually somebody else had previously implemented on a defunct mud. This is interesting. Somebody gave me the database of a defunct mud.
Cool.
Which had stuff on it. And I had to, it was like, jigsaw puzzle pieces because you got simply the database.
Right.
So you could find an object and find things that connects to. It took me like weeks to reconstruct some of this stuff.
Right.
It's defunct database. But
it's interesting. The old adventure games like Infocom, Zork, they were based on Lisp, and the code had objects in rooms, and you could manipulate, take this, move it to this room. So it's the same idea that you're talking about. So you're talking about taking like a Zork game and moving it online and having many people interacting with it, which is like your multi-role player games today. Yeah.
In fact, at Bell Laboratories around 1975, when they had the first Unix machines, Bell Laboratories Unix, there was a copy of the very first dungeon game, the one that the guy,
the adventure,
the Colossal Cave Adventure. So there was a guy at BBN who had written Colossal Cave Adventure in some language, I don't remember what language, and then somebody translated it into Fortran. And because IBM had Fortran, I installed it on the IBM computer, the IBM 360 computer at Bell Laboratories. Installed a copy of Adventure, the Fortran translation of it. So I was very familiar with the Adventure game.
Right.
So in the late 80s, when Tim Maudlin, is it Tim Maudlin? I think that's his name. Well, no, Michael Maudlin. I think that the guy at Carnegie Mellon who developed Julia, the one of the very first conversational robots. So I had discovered, I know what it was. The mud he put it on was called Tiny Tim, which was MIT backwards.
Oh, nice.
That's where the Tim came from.
Cute.
And he was Dr. Fuzzy, I think that was his.
Fuzzy logic.
Michael Maudlin was Dr. Fuzzy, and Tiny Tim was machine. And that time it was running at Worcester Polytechnic, I think the version that I got onto in 87.
Mhm.
He had a version running at Carnegie Mellon, but they ported it over. And Larry Ford added programmability to the original code. You only had exits. So the only way you could program it was you create exits that had behavior. And that was
Okay.
kind of awkward. And then they eventually developed where you could create objects in object-oriented language and put code on them. So the Muse actually had a pretty powerful but arcane, hard to learn, but powerful language. And so one of the first things you build is you build a red balloon. And when you let it go, it flies away. Right?
Okay.
And eventually you learn to build more complicated stuff. So I eventually learned to build logic puzzles and science toys that had actions. Some of them I cribbed off of other sites. Some of them were original. I even wrote a play based on Hofstadter's Tortoise, Achilles and the Tortoise. I created a play with a conversation between Achilles and the tortoise, but it wasn't a conversation that Hofstadter wrote. It was a conversation that I authored.
Cool.
But it was
I love that book.
But it was about Alan Turing.
Okay.
It would talk about Alan Turing. And so you could go to the play and the characters would recite the lines of the play. We had spaceships that you could actually fly because we had a model of the solar system. So they actually had, and I didn't do the spaceship work, another guy did that. But you could have enterable objects. So you could take a car or any enterable object and control it from the inside of the object.
So like, would it follow the planetary rules of dynamics? And so you could slingshot off Jupiter and go somewhere.
Right. The guy who developed the space code actually worked out, the mechanical laws of gravitational mechanics.
Cool.
So you could go into space and visit the moon and other planets and fly your spaceship. That was pretty complicated. That was a guy who was studying aeronautics and astronautics.
Yeah, and I'll just mention, like in the movie Hidden Figures, they show the complication of the math, the analytic geometry to get the ship back into the ocean at the right spot.
Right.
And it turned out converting an elliptical orbit to a parabolic orbit.
Right.
They mentioned that. I found that fascinating.
Yeah. So the space dynamics was a pretty complicated feature of it. But the cool thing was that any participant could create content. And so people would create, for example, I had a friend who was a grad student at Harvard, and he created a couple of Narnia adventures.
Nice.
Reinstantiated these Narnia adventures. And his innovation was that up until then, most of the activities were single user. That is, a single user could do the activity. He created a Narnia adventure where you needed a team of 4 cooperating participants to solve the puzzle, because you had to be on opposite sides of a door or something to,
Okay. Yeah, that's fascinating. That it requires cooperation.
So the characters can talk to each other because it was a conversational room, but you can also then cooperate with some object to where you need 2 or more people to cooperate. So there was one where you had 4 people had to sit in a chair, 4 chairs in a room, and when all 4 people were sitting in the room, then the climax event occurred. And
okay, yeah, you needed the logic to be satisfied, and then the game can progress to a new experience.
So you had multi-participant puzzles and single participant puzzles, and of course, that was state of the art in the 90s. That was state of the art because there was. This is just before the World Wide Web. Because World Wide Web ends around 93.
Right. So this is all text, right?
It's all text. It's all plain text. Although with ASCII you could have colored, adorned.
Yeah, and like with Play-Doh, they were able to do graphics on the terminals that were so expensive. But now you can do Play-Doh on your old computers now.
But you could do ASCII because it was monofont. You could do ASCII graphics.
Right. Yeah, so like for kids who are good at reading or auditory, see, what would be interesting is to take some of that, put it through a speech synthesizer, and have it read to you the descriptions for people who are more auditory. That yeah.
One of the cool things is that when Micromuse got going, initially before it went to MIT, it was running on a small Sun 3 machine.
Mhm.
An undergraduate at Cal State Fresno had started it on a little Sun 3 machine.
Right.
Cal State Fresno, and before he graduated, he wanted to have it continue someplace, and basically that's how I ended up inheriting the system.
Yeah, sure. People
Migrating it.
put
But
so much effort into it. They want
But
it.
here's the funny thing. There were a number of people on it, including, I think there were 3 teenage girls who were on it, who I didn't know who they were, but
Okay.
because they had screen names. But in those days, Hal Abelson had 2 grad students who would come to BBN once a week to talk about developing educational software. And once in a while, Hal would come with them. So one time, Hal Abelson comes over to BBN, and he gets there just before lunch. So we go up to the lunchroom, sit at a big round table, and I knew who he was, but I had never actually met him. And we sit at the round table, and Hal starts to tell a story. He says, he says, I have a teenage daughter who's never shown any interest in computers, but she and 2 of her friends have found this interesting site that they're playing on, and he describes it. And I go, Hal, are you talking about Micromud? And he says, you've heard of it? I said, Hal, I'm molten on Micromud. He said, you're molten?
You're molten? Yeah. It's fascinating how people didn't know each other. I remember when
So
AOL
it turned out it was his daughter. It turned out it was Hal Abelson's daughter and 2 of her friends. So that spring, when the guy at the undergraduate at Cal State Fresno was about to graduate, he made a trip to Boston on purpose to see me, and we went down to MIT to see Hal and his daughter. And
Okay.
at that point, I sprung on Hal the notion that Jin, Stan Lim was gonna graduate, and
Mhm.
on the spot, Hal gives us this Motorola machine
Cool.
to use, and we spent a week porting the code over to this new machine.
Right.
And it ran on this machine in Hal Abelson's lab for several years before he finally said, take the machine. But here's the other thing. His daughter also started a MUD of her own on Hal's own HP machine in Hal's office. And she
Okay.
ran her own MUD for a while she was a teenager. And then by the way, her name is Amanda Abelson. So Amanda and Hal co-wrote a book on Logo for the Mac.
Okay.
And on the back cover of the book, you see a picture of them standing back to back. On the right side, there's Hal Abelson, professor of artificial intelligence, and Amanda Abelson, who runs a MUD.
Nice.
And the cool thing is that because of the MUDs, this is how Amanda became interested in computers. Because up to that time, she was not about to compete with her father. So
Right.
she stayed away from computers
Okay.
and then because of the MUDs, she got sufficiently intrigued, and of course, so did Hal. Hal was Wintermute. Hal's name on the MUD was Wintermute, and I can't remember what Amanda's character name was. Anyhow, so that's how I got hooked up with Hal Abelson, and got a home for the system. We moved it from MIT to UMass Lowell. There's another story in there, and then to BBN, and now it's in my living room.
Yes, I'm wondering, have you ever thought about like saving the source code and putting it on the Internet Archive?
It is, and we basically released the code, and there are many dialects. So there were the original MUD, and then there was the what was the one that Larry Ford? There was Mush, MUD, Mush, Moo, and Muse, and
Okay.
And so most of that code eventually got open source, including our code is open source. It's been open source for, I don't know, 25 years now.
Okay, later, if you send me a link to it, I'd like to look at it.
Yeah, there's 1 or 2 other sites that I think may be running either that same code or a descendant of that code.
Okay, so where is it running now, other than your
So
living room?
MicroMuse itself runs on a Sun Ultra machine in my living room,
Okay, so
running,
it's Unix, right?
it's running System 5, I think version 8 or 9. It's an old
Hmm.
version. It's running
Yeah.
version 8 or 9 of System V, System 5 Unix
Hmm.
on a Sun Ultra machine.
Hmm.
And it's the version of the code that basically was frozen around 1995, I think,
Okay,
93 to 95.
sure.
Although the database that goes, the database can be anything because the participants create the database.
So like, could you use a MySQL if you wanted to, or like, what is it? What database are you using currently?
It doesn't use a SQL database. It basically, it's its own,
Files?
it saves its own database in its own flat file format. So
Yeah, flat files.
yeah.
Okay, so it
So
is theoretically possible.
every
Yeah.
object, an object is either a room, an exit, an object, or a character.
Okay,
A character can be a robot. I mean,
cool.
and every object has a serial number, and then it's
Okay.
just saved as a flat file.
Okay, makes sense. So like, yeah, it could be hydrated into an object in the code. Yeah.
So in fact, because they're saved as flat files, I gained access to a couple of databases of other MUDs
Hmm.
and was
Nice.
able to extract content from them
That's cool.
the hard way and reinstantiate it.
Yeah, but that's great. You just zip it up and it's saved. Yeah, any state
Yeah.
you want to zip up. Yeah.
One of the hardest ones was the restaurant at the end of the universe, which I deconstructed from somebody else's database and recreated on MicroMuse.
Mhm.
So there were several of them that I reconstituted that way from other sites, or just wrote from scratch, sort of knowing what they were.
Yep.
Various puzzles and activities and things.
Hmm.
And the kids, are a lot of teenagers on it, and they did a lot of the work and created a lot of content. So there's now it's a ghost town today because we're talking about work that was done in the mid 90s.
Right, but that's fascinating that the kids had enough experience, they were able to design their own
Oh yeah,
content, and that I would love to see go forward,
yeah,
where young people can contribute to the evolution of a course. Like the
yeah.
professor shouldn't know everything, and it's that creativity that comes out of the interaction that can enhance new paths, new branches in a course.
There was an activity called coding with Cooter. Cooter CDR is
Okay,
CDR was the name of a command in assembly language.
okay,
Something in decrement the register, I think.
got it. Oh, yeah,
Anyway,
Cedar in Lisp, there's a
in
Cedar, yeah.
yeah, code CDR, something decrement the register. I can't remember what the C stood for.
Yeah,
Anyhow,
well, car is contents of address register, Cedar is contents of the data register. It's like the rest of the
yeah.
list. Yeah,
So
first,
so
yeah,
that was an early activity, and Cynthia Solomon might actually have known about it.
probably.
Ruckman, I think, did something with it. So the notion of learning to write code on a MUD,
Oh, cool.
and it was object oriented, which in those days was pretty new stuff.
Right.
So there was a sort of the golden era, the heyday of coding in MUDs. There were a couple of public schools that I gave access to. I actually gave them computers and terminals and things that were being retired from DEC and others.
Yep, that's what people are doing. They're collecting old stuff now. People have
Right.
their basements full of stuff.
So
Yeah.
there were a couple of schools that had MUDs and they were used in the school with the teachers and the students, and they would do projects. They would take their subjects and create little content on the MUD and share it with their students. And of course, they were learning spelling and grammar and coding and
Oh,
and
isn't that amazing? Yeah, it's integrated learning.
right.
All your subjects in one place, and
Yeah.
you have transitions between subjects. It's,
Yeah,
yeah.
the principal at one little school was absolutely amazed at how quickly these students were gaining ground in their language skills and spelling and punctuation
Mhm.
and the the applied math, and
Yeah, when it's all text, it's using your imagination to
Right?
visualize what you're looking at
Pictures
rather
are in
than
your head.
having the picture thrust in front of you
We,
like
we,
today.
we won
Yeah.
a number of prizes back in those days, and some
Wow.
students won prizes for their work.
Hmm.
And by the end of the 90s, with the advent of the dot-com boom
Sure.
and the World Wide Web, the era of the MUDs kind of faded into the niche background. There were still a few diehards in it, but it basically
Right.
faded away pretty much after the millennium.
Yeah, because then you had all the online services getting on the internet.
Right.
So yeah, and then yeah, like there was CompuServe online education that Margaret Morabito worked on.
Right.
Yeah. So yeah, I'm fascinated by what we had, the value that we had,
It
and
was very
yeah,
heady, because you're talking about, you're on 1200 baud lines on
yeah,
a terminal, and this was the best, this was the frontier back in those days. Of course, the frontier moved beyond it. Uh,
yep, yeah. I had a 2400 baud modem eventually. Yeah.
but I was sort of playing, the role of Moulton to these, a few dozen really bright kids. We had some really
Hmm.
bright kids on.
Yeah.
And it was a very heady time, and these kids were learning like crazy. They were just learning.
Yeah. So I'm wondering if we keep these resources alive, they could become paths for motivated students to explore specific topics. Like, say, someone's interested in physics
Yeah.
and they want this could be put into a recommendation engine like Liza Loop is developing. And based on the profile, if you see that this person is really highly motivated to learn physics, it could be like recommended as an emulation that they go to the Internet Archive and play with online, and it's text to really, and even like a historian, someone interested in the history of education could use that to experience the text interaction and the imagination that it required. Okay, you're in a spaceship, you're going to Mars, and uh-oh, here's radiation coming from the sun. What do you do? Yeah.
So from a historical point of view, it was important pioneering work.
Hmm.
It sort of demonstrated the possibility, and of course, it was just totally unfunded. Micromuse was completely unfunded. They were
And that's what's
machines that were
amazing. Yeah.
machines that were given to us because they were basically, surplus and retired machines. So there was no money involved.
Yeah, and think about the open source movement. People are volunteering to code. They're at hundreds of hours sometimes
Right.
to code because they love the topic. They love they want to contribute something of their knowledge. And
And it was
that's,
community
yeah,
building. The other
yeah,
thing was,
community.
so
Hmm.
we were on one hand, we were building community. We had online virtual communities.
Hmm.
So part of it was the community building aspect without regard to the technology. And then there was the technology half of it, which is creating content, which is involved coding and all. So you had
Sure.
this mix of community and socializing, and also, conversing in text, the chat mode.
Sure.
And it was quite a remarkable passage in the early, for about 5 years in the early 90s, until it
Yep.
got sort of overtaken by the World Wide Web.
Right. I guess Plato had a similar uh, evolution because a lot of the things like the message boards and interactive chat,
Right.
a lot of the concepts evolved from those students who
Yeah.
had it.
I mean,
Yeah.
we added a web server. A 14-year-old boy installed Apache for the first version of it.
Cool.
And you can, by the way, you can still go on and still see his original page.
Wow.
You can, I mean, my very first web page was on, it still is up on Micromuse.
Yep.
So you can go back and see, these web pages that the students put up.
Okay. So like, do you have a website where you have all these links somewhere that for
Yeah,
people
I
who want to
do.
explore it? Okay. If
I
you could
do.
send me that later, I'll
Yeah.
send it out.